Hi, this is Hallicrafters Rehabs, and this is an odd way to start a simple video on putting in Bluetooth on my SX-71, but I've been doing a lot of studying and a lot of testing on this receiver, trying to reverse engineer the gain calculations, maybe, or the gain measurements, or the factory gain specifications in the service manual. And after a lot of study, I've pretty much come to the conclusion that I can't really, there's too many variables involved. I have been able to come within an order of magnitude in some respects what the service manual says, but for the most part, in my opinion, it fails the reasonableness test, because I've done a lot of calculations, I've done different measurements, and there's two primary reasons why it's just, unless somebody knows something and can add something to the question, it's probably not reverse engineerable to the point where you could use this as the values that are given in the service manual as a basis for testing the radio. Now, the first issue I come up with is, and let me get my marker here, nomenclature of all things. In the service manual, and I don't like that picture. I think the biggest issue in doing videos is glare and lighting. Certainly when you use these little whiteboards. But anyway, as I was saying, the nomenclature created a problem. In the schematic diagrams, the Hallicrafters schematic diagrams, after the converter, the 6BE6, they label this transformer, the first IF, they label the 6AU6. No, that's the 6BE6, right. And so they label the first IF as the transformer coming out of the 6BE6, and then they label the second IF as the transformer coming out of the 6SK7, but the 6SK7 is the first IF amplifier. And I struggle with that a lot. I've done a lot of studying. And in reality, if you back in my Fundamentals of Radio 1938 edition book, and I found this document. It's actually the British Post Office Telecommunications educational pamphlet on the super heterodyne receiver. And if you like tube radios and you like to restore them, I recommend you find this on the internet, Post Office Telecommunications Educational Pamphlet, the Super Heterodyne Receiver. This had to have been written by a genius, because they wrote this for an average person who's not familiar with jargon, and it goes through and answers the why and how all the way through the stages of a radio. Just to say this, I saw this configuration just to the schematic, and it makes all kinds of sense in the world. Now, we don't normally see these kinds of tubes anymore where you have a triode and then a pentode kind of hooked together in the same one. Sometimes you'll see that in older sets. They're separated out. There'll be an oscillator tube, and then there'll be a pentode, which is the mixer. But look how they have positioned the IF, so to speak, transformers. First of all, they call this a frequency converter. I had not heard that term before. We do you call it converters, and we call them mixers, and we sort of intermingle those words, but they actually are specific terms. And then this is an IF amplifier, and what they do is they are off the plate. They are actually a band pass configuration to pass the signal from the plate to the next stage, and they're tuned, in this case, for the converter, the frequency converter as they call it. The primary side receives the frequency of the incoming signal plus or minus the frequency of the oscillator. And the frequency of the oscillator is always, in the case of this, 455 kilohertz, or the IF frequency above, that's the one that's selected, is 455 kilohertz above the desired signal. Now we'll take a look at the radio just for a second. Okay, so this is going to be a little cumbersome because I'm hand holding this and doing all kinds of things here. But when you align the radio to the dial, I'm not going to take the cover off here, but this is the oscillator section, and there are coils with screws in there, and in the case of this, or slugs, and in this case they're always trimmer capacitors, but sometimes you'll find a radio where there's a slug in the coil. Then this does have a slug in it. These are the second adjustments for the dial on the oscillator. So what you're doing actually is you're not, when you have a signal generator, say set to, we'll move this down to 1,000. All right, it's set to 1,000 on the dial. The signal that you're adjusting is 1,455 kilohertz. So 1,455 kilohertz is what the receiver, let's see, is what the dial is saying 1,000, but it's actually getting at 1,455 kilohertz at this point in the radio. I hope that's making sense. So essentially this the dial is part of the circuit in that sense, because the dial is giving us a reading of 1,000, which corresponds to an oscillator that the coil here is resonating at 1,455 kilohertz above whatever signal you're putting in here. Now I'm finally saying it right. Okay, so what the signal going through these coils is 1,455 kilohertz above the RF generator signal that you're using as a standard. And then on the dial, you're setting it at 1,000, you're subtracting that value with the dial. Now we'll go back. Okay, so the whole thing about this came about to me just by the virtue of drawing this transformer, not in the way that you normally see on a schematic, but actually as filtering, resonating the signal coming from the plate. Then the secondary, so coming out of here is the signal plus 455 kilohertz and one minus, but that's filtered out. And on this side is tuned exactly to 455 kilohertz. So the only thing that is sent to the next part is that difference between the signal coming out of the plate and the desired signal. So that's where 455 kilohertz essentially gets, the carrier frequency gets stripped down to 455 kilohertz right by this side. This is the frequency converter, the way they put it. This is the IF. So this is this tube then, a pentode, is an IF amplifier, and that signal goes through a bandpass amplifier, as my Principles of Radio book calls it, which is strictly concerned with selectivity and sensitivity of the 455 kilohertz signal from here to the next stage. On that basis, then, if we were to draw this up here, and I'm not going to go through all that, I would not call this the first IF. I would call this the first IF transformer, and this the first IF amplifier. This is an IF amplifier stage, not this. Excuse me. So that creates a problem, because the other question then is the gain from grid to grid, or is it gain from plate to plate? And I came closer with all my manipulations of everything to what these within the, I would say, an order of magnitude of what the gain specifications were in the manual by measuring plate to plate. That and just 1 second here. Okay, so the other issue that I had was I really don't know if the gain was in terms of voltage gain or wattage gain. Pretty important difference, because it's a factor of 2 between the two. So with that, I just gave up. So we're now going to go into the first of 2 mods that we're going to do on this radio. And let me get the pages. All right. So I want to install Bluetooth, because I don't like reaching in the back of the radio to the phone in the back and or to have a cable sticking out or all that kind of stuff. It's so easy to do. But the step 1 is to have some power for a Bluetooth adapter. Now, I just went out bought one of these auction, let's see, KRC86B. This is version 4. There's not a whole lot of documentation on it. I looked hard. I don't think I threw the instructions away. I don't think there was. But if you go on to, who was it? I don't say. But if you go to some of the auction vendors, they'll actually have this diagrams that I showed you for it. Okay, so the Bluetooth module is a little cheap auction version that's out there. Actually, we'll see how well it works, but it operates off of 5.5 volts positive DC, and we do have a source of DC that's safe to use on the radio, which is 6.3 volts on the heater AC line. So you have to rectify it, and this little rectifier here is really featured in Mr. Carlson's Lab YouTube videos, one of which is called Design and Build a Buffer Circuit, Tube and Transistor. And there's also more information on his Patreon channel, which I highly recommend. Learn a lot about electronics on it. But he's used it several times, an early version for his Hammerland HQ120, and then he uses again for a buffer circuit and then for other things. So it's just simply rectifying the heater AC supplies, 6.3 volts, and giving about a 6 volt or plus DC output. Now that's a little high perhaps for this little board that we're going to put in, but I also will test a few simple, like 100 ohm resistor and a few other things. And there wasn't much in the way of instruction, but with the aid of some visual aids, that's how you do the LED. Sometimes I have to watch this while I'm soldering just to make sure I'm doing it correctly. I've put this onto a little solder terminal. So let's go look at the radio and then we'll go see how it works. So we're looking at a simple terminal strip. There are lots of places to screw those into the radios like this. The 6.3 volt AC comes in from the filament lead to this point, goes through the resistor and then the diode and the capacitor and then the electrolytic, and then it comes around to the front where I've mounted the board. So what we're going to do is we're going to test this, see if there's going to be smoke. Now I need to also, this is not going to work. Okay, so I'm just going to hold the meter. I've got it tacked in right now just on one side, and we're just going to look at voltage and hopefully no smoke. Oh, that's supposed to be DC. And we're waiting for the inrush current limiter to warm up. And I see nothing happening. Okay, after discovering a wiring mistake, here's take two. Okay, it's going up to 8 volts, so we're going to have to cut that down with some resistance there. So That's where the fun starts. Alright, we're ready for take 3 with 100. I got a 100 ohm 1 watt resistor just as a cut it down a little bit. This is unloaded also, so it doesn't drop it all that much. 8.4. This will take a little more drastic measures. Alright, give it another shot. Okay, so this is 1,000 ohms, 2 watt resistor, and that's probably what I'm going to go with. 7.6 unloaded, but we'll see how it works. Okay, so I have it mounted on the front face, which is covered by the cover of the front, and the 1,000 volt ohm 2 watt resistor in series. I've deliberately not soldered it, it's just sort of touching, and either we're going to have smoke or we'll see a flashing light. Or nothing. You know? How about connecting up the voltmeter? There we go. Let's try again. Two and a half volts. So there's a big difference between loading and unloading. So it's not enough voltage to get it started. So we'll take that 1,000 ohm out and we'll put in a 500 ohm and see how that works. Okay, I found a nice 330 ohm ceramic resistor I recycled from an old portable phone, and either we're going to have smoke or a flashing blue light, and let's see how that works. 3.5, not enough voltage. We may be going back to that 100 ohm resistor, sure enough. That's not enough to fire up. Okay, so as Maxwell Smart said, would you believe 22 ohms? And that is what got it working. So now, well, the last step is to wire up the sound. That fits in there nicely at that point. I'll loom it up here in a minute. And in the back, we're set to go. We're actually going to wire it right into the phono input. Now I could use the switch side, but I didn't because there's not a convenient ground, and so I just twisted the wires together, and then we're just going to do it in the back here and see how that works. Alright, we are soldered in, and we're ready to give it the big test. I'm going to get my phone. Okay, so now all the wires are loomed up and connected. We're going to give it the big acid test here. Alright, we're linking up with the phone. We're linked. Oh, I should have a speaker attached. Let me do that. I'll be right back. Okay, So everything is wired up. I got the sound wired up. I have loomed all the wires and everything inside. So let's give it a shot. It's phono right now. Pretty good. Pretty good. Alright. That's enough of that. Anand Radio Hindi Masihi Sangeet, which means Joy Radio Hindi Christian music. So that's what you're listening to, and yet this receiver now has Bluetooth on it. The last thing, the very last thing before it receives its place of honor in our shack here will be to put in the buffer circuit and the digital display, and there'll be some experimentation with that also. This is Hallicrafters Rehabs. Thanks for watching.